Hey everybody, we're back talking about more Algebra 1. In this video, I will continue off of what we were talking about in a prior video. We are going to be talking about solving systems of equations using the elimination method. Now, previous to this video, we had talked about elimination method before, and I referred to that as part 1. That lesson over elimination method was very simple. We were just adding or subtracting equations where one of the variables had a common coefficient. Now today we're back talking about this because we want to answer the question, what if there are no common coefficients? So we're going to look at elimination method in a more advanced way today. And really the response to this question is already written here. We're going to have to multiply one or both of the equations by some number to create matching or opposite coefficients. Now I'm throwing a word around that word, coefficients. Do you remember what it means? Well, coefficient is a number that describes a variable. So take the example 5x. Well, we know that x is the variable because it is an unknown quantity. That means the 5 is our coefficient. It is the number in front of the variable, and what it does is it tells us how many of the variable we have. So compare it to like 5x, perhaps it's 5 gallons of gas, and gallons are the variable because I don't know how many I got. Maybe it's something like that. So what we're going to be looking at today is we're going to try to see what numbers we have to multiply so that two variables, whether it's x or y, have the same coefficient. So recall from our last video, the first step that we need to pay attention to is that our equations are lined up perfectly on top of each other. So in other words, I have an x over an x, I have a y over a y, and a constant number over a constant number. Remember that we want the equation symbol to also be in the same place. So if x and y are both to the left of the equation symbol, we want the x and y of the second equation to also be to the left of the equal sign. So looking at number 1, we're going to just dive right into this. With number 1, I can see that our equation is actually lined up very well. I have that x over an x, I have a y over a y, and I have a constant over a constant. And notice that the equal sign is what helps distinguish our orders. So luckily enough, we don't have to worry about moving things around. Everything's lined up. Now previously, we would have looked for the variables that have the same coefficient. But as you see here, neither x nor y have the same coefficient in the equations. So now we have to actually work on multiplying one of these equations to get it so that the variable, the coefficient of one of the variables, matches the coefficient of the other variable in the second equation. Tripping over my words a little bit, but stick with me on this. So I see that x plus 3 is equal to 6, and 2x minus 7y is equal to negative 1. There's a bit of an art or a trick to this because we can't just multiply either variable. We have to ask ourselves the question, multiplying which equation is actually going to get me to match nicely with the equation at the bottom. So what do I mean by that? Well, take for instance the first equation. I have the 3y, right? Is there any number I can multiply that by to get to a negative 7y? The answer is no. 7 is not a multiple of 3, so that's not going to work. We can actually look at x then, and this is the thing that I'm trying to point out. Notice that up here I have a 1x, and then in the bottom equation, I have a 2x. Can I not multiply 1 by 2 to get a 2x? Absolutely. So now we have an idea. We want to multiply this top equation by 2. That way, our x's will have the same coefficient. So I'm going to multiply this, and when I multiply this, what I'm actually doing is I'm distributing. I'm going to distribute this 2 to the x, I'm going to distribute it to the 3y, and I'm going to distribute it to the 6. So I'm actually going to bring my stuff over here, and I'm going to bring both equations over, but I'm going to do the distribution to simplify that first equation. So when I do the distribution, I'm going to get 2x plus 6y equals 12. That is, of course, because 2 times x is 2x, 2 times 3y is 6y, and 2 times 6 is 12. There. So now that I've done the multiplication, My equations are still lined up, and now my x's have the same coefficient. Now we can just do what we did in the previous video. Since I need the x's to cancel out, that's our goal. We want the x's to cancel out. I know that I'm going to have to make one of these a negative. So I'm going to go ahead and subtract the bottom equation. And the point of this, the point of me putting the parentheses, so I clarify, whenever we subtract one equation from the other, we are essentially distributing this negative, the minus, to each of these values inside the equation. So this will become, follow this, this will become 2x minus 2x. Then I'll have the 6y minus negative 7y, with all these equal to 12 minus negative 1. That's really what it comes down to. And using our elimination techniques, the x goes away. 6 plus negative 7 will become 13y. And this is equal to 12 plus 1, which is 13. Now, of course, we want to get y by itself, so we have to get rid of the 13 by dividing. I'm going to bring my work up here. Divide both sides by 13. We now know that y is equal to 1. So what do I do with that? I'm going to take this y equals 1, and I'm going to follow the same steps as we did previously, and I'm going to plug this back into one of these equations. Now, really, it doesn't matter which equation. I just like plugging it into the top for simplicity's sake. It's just quick and easy. So I'm going to write this up here. 6 plus 3y equals 6. Now, of course, what we need to know is that y is equal to 1, so I'm going to end up swapping out the y in that equation for 1. So this is x plus 3 times 1 equals 6. Or if we wanted to simplify that, x plus 3 equals 6. Now it's just getting x by itself. And to do that, I subtract 3 from both sides. Those 3's cancel out. And x is equal to just positive 3. Right? Now we're not done yet. The last thing that we have to do is write these two numbers as a coordinate point. Remember that we will have one of 3 types of solutions for a system of equations. It'll either be a coordinate point, no solution, or infinite solutions. Now, because I have an x and a y, I know that I have to write a coordinate point. Just like that. So the solution to this system is 3, 1. I will go ahead and move this up just a little bit so we see 2. Switch up my color because I like doing that. I have these two equations in number 2. 9x plus 3 equals 9x plus 3y equals 12, and 2x plus y equals 5. Now, once again, I mean, they're lined up, and we wanted to check that first. They are lined up. I want to find the variable that I can multiply to get one of the others. So if I look at x, let's always start with x first. If I look at x, I need to ask, is there a way that I can go from 2 to 9 or 9 to 2? The answer is no. 9 is not a multiple of 2, so there's no way I can actually do that. Not by whole numbers, at least. But if I look at the y's, I want to say to myself, well, I see a 1y and I see a 3y. Is there a number I can multiply that 1y by to get a 3y? And of course, you're saying to yourself, 3. So what I'm going to do is I'm going to multiply down here by 3 in order to get a 3y. So the top equation will remain the same. 9x plus 3y equals 12. Now the bottom equation, don't forget that I'm distributing this 3. I'm going to try to keep this like that. Distributing the 3 is going to give me 3 times 2x, that's 6x. 3 times y is 3y, that's exactly what I wanted. And 3 times 5 is 15. This is exactly what we wanted because now the y's have the exact same coefficient. Now we can actually add or subtract. And since I want them to cancel out, I'm going to have to subtract. All right, this is now the review part from what we did last time. So let's just go ahead and do this. Remember that we're going to have to distribute that negative. So this will be 9 minus 6. 9 minus 6 is going to be 3x. 3 minus 3y minus 3y, that's going to be 0. So I'll put 0y. And this is equal to 12 minus 15. 12 minus 15 is, of course, negative 3. Now remember that 0 times anything is going to be 0, so that 0y is going to go away. So now 3x is just equal to negative 3. And if I want to find out what x equals, and I do want to find out what x equals, I divide both sides by 3. This way, I'm getting x all alone, and I can find that x is equal to negative 1. Now remember, we're not done yet. We want to find out what both x and y equal to see if we can find the solution to this system of equations. So I'm going to take this x equals negative 1. I'm going to plug it back into that first equation. So 9x plus 3y equals 12. And we now know that x is equal to negative 1. So I'm going to take that negative 1, and I'm going to swap it out with x, like this. So we still have 9 times negative 1 plus 3y equals 12. 9 times negative 1 is going to be a negative 9. We still have the 3y. And we want to get y by itself, so I'm going to add 9 to both sides as I run out of room real quick here. 12 plus 9 is 21. If we divide both sides by 3, we should find that y equals positive 7. That's real tight on the spacing, I know. But now I find that x is equal to negative 1 and y is equal to positive 7. I can write that as a coordinate point. So negative 1, comma, 7. Okay. And last but not least for this first page, we're going to try and do this even faster than we've done it yet so far, because we want to try to move on. I'm going to zoom in. I'm going to change things up just a little bit. I'm going to zoom in just a little bit. That way spacing is not as much of an issue as it has been so far. So same steps. The equations lined up, that we don't have to worry about. We want to look at variables and see what we can multiply in order to get either x or y to cancel out. So looking at this, I see 3 and 5. Can I multiply 3 by anything to get 5? Absolutely not. But can I multiply this 1 by anything to get 4? Yes, I can. I can actually multiply then the whole top equation by 4. Whenever you see, this is the big hint that I have been kind of missing. Whenever you see that the variable coefficient of 1 arises, or whenever you see x or y has a variable as a coefficient of 1, you want to use that. Use that and multiply it by whatever number the other y or x is. So let's go. Hyperspeed. When we multiply this equation by 4, we're distributing. 4 times 3x is going to be 12x. 4 times negative 1y is going to be negative 4y. And 4 times 14, that's going to be 56. Then we've got the 5x plus 4y equals 12. Now, awesome enough, we see that the 4y in the top is negative and the 4y in the bottom is positive. So those two values will actually cancel out as they are. So what we're actually going to do, because they are different signs, we're going to add. And when we do this, that's going to be a 0y. I'm going to have 12 plus 5. That's 17x. So 17x plus 0y is equal to, this looks like it's going to be 68. And when I bring this down here, this is going to become 17x is equal to 68. If I divide both sides by 17 to get x by itself, I find that x is equal to positive 4. Now, of course, we're not done yet. I still have to take this and plug it into one of the equations. I think this time I'll plug it into the bottom equation. Remember, we can plug this into either equation. It doesn't matter. So let me see here. 5x plus 4y equals 12. That's the equation I'm plugging this into. But now that we know that 4 is equal to x, or x is equal to 4, either one, I can swap out that x up there for a 4. So now it becomes 5 times 4. we are adding 4y equals 12. I can simplify the multiplication. So 5 times 4 is going to give me 20. I've still got 4y equals 12. Subtract 20 from both sides because now we're trying to get y by itself. 4y is now equal to negative 8 because 12 minus 20 is negative 8. And to get y completely by itself, divide both sides by 4. Y is equal to negative 2. Don't forget, write this as the solution to my system of equations. X is 4, y is negative 2. Okay? We're going to go ahead and change pages. We're going to look at a few. We might skip around here or there. But the purpose that we will continue off of, actually, we can skip number 6 as I even look at that. Look at this. So if we look at number 6, I see that I've got a coefficient of 1 here. Well, guess what that means? I can easily multiply this top by 2, so that way I get a 2y here and a 2y here. That's just in a nutshell what we would try to do. If you see a coefficient of 1, just go ahead, choose that equation, and then multiply by the number of the variable, by the coefficient in the bottom. To keep my spacing, I'm going to go ahead and zoom in yet again. Okay. Now we're looking at 8 and 9. We're going to look at 8 and 9 for this very specific reason. Both of these have the equations lined up already, which is fantastic. That's amazing. But as you'll notice, not one variable in any equation here has a coefficient of 1. Now, all of these coefficients are greater than 1. And in some cases, they'll be less than 1. That goes without saying. But here I have a 3x and a 5x. Then I also have a 3y and a 4y. Now, what this actually means, the questions that we have to ask is there a way for me to get from 3 to 5? The answer is no. Is there a way to get from 3 to 4? The answer is no. So we're actually going to have to multiply both equations as we implied at the beginning. We're going to have to multiply both of these equations, perhaps by some different number, in order to get these to line up the way we want them to. So, which would you rather do? Do you want to do 3 and 5 or 3 and 4? I'll tell you what, I'm just going to go with 3 and 5 to make it simple. We're just going to work on the x's. So the question then is, what is a number that both 3 and 5 go into? Hopefully you're saying 15. 3 and 5 both go into 15, so I'm going to multiply both of these equations by the numbers it would take for x, the coefficient of x, to reach 15. So to make that 3x a 15x, I'm going to multiply the top by 5. And then to make that bottom equation, 5x, go to 15x, I'm going to multiply by 3. Now this is going to give us these new modified equations. Look at this. When I distribute in that 5, 3x times 5 is going to give me 15x. Then we've got plus 3y times 5. That's going to give me 15y. And this is equal to 9 times 5, which is going to be 45. Now in the equation below, I'm going to have 5x times 3. That's going to be 15x. Plus 4y times 3. That's going to be 12y. And this is equal to 10 times 3, which is 30. Okay. Now as we look at the 15x's, that's exactly what we wanted, right? We wanted our x's to have the same coefficient. So now that they have the same coefficient, we can go ahead with adding or subtracting. Now, as you've already seen half a dozen times by now, whenever we have the same sign, we're going to subtract, because I want these 15x's to cancel out. So I'm going to subtract, and don't forget that this is basically distributing a negative. So this will be 15x minus 15x, which will be 0x. Next, I will have 15y minus 12y. That's going to be a positive 3y. And then I'm going to have 45 minus 30. That'll be positive 15. If I take out the 0x, because 0 times anything is 0, I have left 3y is equal to 15. Now the goal again is still to get y by itself. I want to know what y equals. So I can solve for y by getting it by itself. That means I have to divide both sides by 3. When I do that, we find that y is just equal to 5. Okay? Now, once again, we're not done because we want to find out what x equals. So I'm going to take this y equals 5, and I'm going to plug it into one of these equations. And you know what? I'm going to go back to using the top equation. I want to use the first equation. So if I look at this, the first equation says 3x plus 3y equals 9. And now that I know what y equals, I'm going to plug that 5 in for y. So 3x plus 3 times 5 is equal to 9. And when I simplify the multiplication, I find that 3x plus 15 is equal to 9. Now we're just solving for x. This is a two-step equation, nothing we haven't seen before. I'm going to subtract 15 from both sides to get that to cancel out. So now 3x is equal to 9 minus 15. That's going to be -6. And then last but not least, I'm going to divide both sides by 3 to get x totally alone. -6 divided by 3, -2. Don't forget, write this as a coordinate. So x is -2, y is +5. Just like that. Okay. The last example we'll do in this video is number 9. Once again, thinking about it, are the equations lined up? Yes, they are. Now what we want to do next is we want to look at x and we want to look at y. Neither of those variables have the same coefficients. We have a 5x and a 7x, then we have a 9y and a 10y. So what we want to do is we want to multiply both equations by something that's going to get either the same number of x's or the same number of y's. Now, if you want my personal opinion, it may be better for us to work on the 5 and the 7, because if we start looking for numbers common between the 9 and the 10, those are going to become some huge numbers real quick. So what's a number that 5 and 7 go into? 35. Hopefully that's what you were thinking. It's easy enough, because if we thought about it, 5 times 7 is just 35. Here's why I want to avoid the y's. If we did 9 times 10, that'd be 90. That's quite a few y's to have. So how do I get from 5 to 35? 7. So I'm going to multiply the top by 7. And then how do I get from 7 to 35? Multiply by 5. So I'm going to multiply by these to get it so that my x's have the same coefficient. So 7 times 5 is going to be 35x plus 7 times 9. That's actually going to be 63y. Looks like my y's got big. And this is equal to -10 times 7, which is -70. Okay. As for the bottom, 7 times 5 is 35. And then I've got plus 10y times 5. That's going to be 50y. And this is going to be equal to -1 times 5, which is -5. Looking at my x's, I can see that they have the same coefficient. They're both 35, which is exactly what I was looking for. I wanted them to have the exact same coefficient. It just so happens I had to multiply both equations to get there. Now these coefficients, 35, have the same sign. In other words, they're both positive. And because that's the case, I want to cancel these out, and to do that, I'm going to subtract. So I'm going to subtract 35x from 35, but remember that whenever I subtract equations, this is distribution. So this will become 35x minus 35x. That will be 0x. Then I will have 63y minus 50y. Luckily enough, that comes out to be a positive 13y. And then I'm going to have -70 minus -5. -70 minus -5 becomes -70 plus 5, and that will be -65. Now when the 0 disappears, the 0x, I have 13y is equal to -65. And to get y all by itself, we divide by 13. So now, y is equal to -65 divided by 13, which is -5. Now that we know what y equals, we need to plug it back into an equation in order to find what x is equal to. So I'm going to go ahead and plug this into one of those equations. Why not? Let's just put it in the top one again. If you can't tell, I do love myself the top one. So 5x plus 9y, that's the equation I'm using. Since we now know that y is equal to negative 5, I'm going to replace y with that negative 5. So 5x plus 9 times negative 5 equals negative 10. And then basic multiplication tells me 5x minus 45 equals negative 10. Now we're solving for x. We're going to add 45 to both sides to get rid of it first. We get that 5x is now equal to, believe it or not, 35. And just like we did in the beginning, to get x all by itself, we're going to divide by 5. We find that x is equal to 7. Last step is, of course, write my answer as a coordinate point. So x is 7, so 7 goes first, and then y is negative 5. My solution to this system of equations is 7, negative 5. I hope you found this to be somewhat helpful. We'll be seeing you later. In the meantime, I hope you have a great day.